Let's take a look at the following example. I'm going to give you another function like f of x equals to, here you have 2x plus 1 over x plus 1. So based on the definition, you have some expressions divided by another expression. It is a rational function. Okay, now that you have a rational function, you need to know how to find the domain. You need to know how to find the vertical asymptote and how to graph this function. To find the domain, follow the definition. You have a curly bracket, write it down. You have x, copy x down. You have a vertical line such that with the condition that qx cannot be 0. What is qx in this case? Qx is x plus 1. X plus 1 cannot be 0. We learn algebra. We know how to do algebra. We need to simplify this. It's the set of all x values such that x cannot be negative. So if I ask you to graph the domain of this function, you're going to say, hey, I have 0, some positive numbers. I have some negative numbers. It excludes -1. X cannot be -1. It means that it excludes -1. So we're going to put an open circle here to show that you are excluding -1, and shake the rest of the numerical values on the right, on the left. Another way to represent this is negative infinity. We stop at -1. We have a hiccup here, and union with -1 to positive infinity. Sometimes they write it this way. They say, hey, you have all real value except -1. All real line minus -1. You're excluding -1. Okay. Now for vertical asymptote. The vertical asymptote is the vertical line x equals to -1. If I plug in -1 into the function, I get something that is not defined. Take a look. F of -1 is 2 times -1 plus 1 divided by -1 plus 1. You get -2 plus 1, -1 divided by 0, which is not defined. What's the meaning of that? It means that the vertical line, x equals to -1, is a vertical asymptote. So let's try to graph this. So here you have your x-axis. Here you have your y-axis. We know x equals to -1 is a vertical asymptote. So we're going to quickly graph the vertical asymptote. This is the vertical line, x equals to -. Now for the graph of the function itself, plug in different values. X, f of x. If x is equal to 0, I end up with 1/1 or just 1. So at 0, I have a 1. If I plug in 1 into the function, I get 3 divided by 2. So at 1, you have 1.5, which is going to be here. So far, the behavior of this function looks like this. Very good. And if we plug in, for example, -1/2 into this function, see what's the behavior. So I have 2 times -1/2 plus 1 divided by -1/2 plus 1, -1 plus 1, which is 0 divided by 1/2 or 0. So if I plug in -1/2, I get 0, right? So it seems like this function, this part of the graph, behaves like this. It never touches the vertical asymptote, and it goes this way, right? Let's plug in more values, right? This is the way of point plotting work for us. So suppose we plug in some negative values. We want to know what is the behavior of the function on this side, x and f of x. -1, we know we cannot plug in -1 because we get a vertical asymptote. So let me plug in -2. -2, I get -4 plus 1, -3 divided by -1 or just 3. So at -2, I have a 3. Let me plug in, for example, -3 as well. If I plug in -3, I get -5 divided by -2 or 5 over 2. 5 halves. It starts getting smaller. So we expect the behavior to be like this. If you plug in another value, the behavior of the function is going to be like this. So as you can see, the vertical asymptote divide up the graph into 2 pieces. We have a discontinuous function. Discontinuous function. There is discontinuity with the graph of this function. One part of the function is on the left, the other part is on the right hand side.